In this session, we are going to solve problems on half-range Fourier series. Here the problem is obtain half-range Fourier cosine and sine series of the function f of x equal to x in the interval 0, pi. So to the function x, they ask find half-range Fourier cosine series as well as sine series. So the solution is given f of x equal to x in the interval 0, pi. We have to find half range Fourier cosine series first of all, and later we determine Fourier sine series. Half range Fourier cosine series to the function f of x means given by f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx. Half range Fourier cosine series means it contains only a0 and an terms. Half range Fourier sine series means it contains only bn term. Particular we are finding now half range cosine series, that is given by f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx. Here a0 and an are Fourier coefficients we need to determine. So to find a0, the formula given by a0 equal to 2 by pi integral 0 to pi f of x dx equal to 2 by pi integral 0 to pi f of x, the given x, so x dx. So 2 by pi integral x means x square by 2, limits 0 to pi. So by substituting upper limit pi square by 2, lower limit value 0, pi cancel, 2 cancel, so a0 equivalent to pi. Now to find an. To find an, formula is an equal to 2 by pi integral 0 to pi f of x cos nx dx. It is equal to 2 by pi integral 0 to pi f of x is x cos nx dx. Now we have to evaluate the integral. Under the integral, algebraic and the trigonometric function. So to evaluate this, we have to go for generalized rule of by parts. For that, choose algebraic as u, that is let u equal to x, and b means cos nx. For u, you have to do the derivatives u dash 1, u double dash 0. For v, integrations, v1 equal to integral of v, that is integral of cos. Actually derivative of cos is minus sine, so integral of cos is sine. So sine nx by n. v2 equal to integral of sine, that is minus cos nx by n square. Generalized rule of by parts formula is integral uv dx equal to uv1 minus u dash v2 plus u double dash v3 and so on, like that continue. So just keep the formula in mind and observe these symbols and try to substitute it. 2 by pi integral uv dx equal to uv1 u into v1 minus u dash v2. v2 contains 1 minus sine, so plus sine, it is cos nx by n square. uv1 minus u dash v2 plus u double dash, the term 0, so the formula will be stopped. Limits 0 to pi. So 2 by pi, by substituting upper limit pi, sin n pi you will get the value 0. So first term 0. Cos n pi, that is minus 1 whole power n by n square. Upper limit substitution minus of lower limit substitution, 0 into this term 0. Cos 0, that is cos 0 1 by n square. So on simplification 2 by pi minus 1 whole power n minus 1 by n square, and this is an. Therefore an equal to, so in particular if n, so in whatever the problems, if you have like these expressions, if n is even, once observe what is the value of an. If n is even, you will get 1 here. 1 means 1 minus 1 0. So if n is even, you will get an equal to 0. If n is odd, for n equal to 1, 3, 5 like that, you will get minus 1. So minus 2 by n square. So minus 4 by pi into n square. This is an value. If n is even, an 0. If n is odd, an becomes this value. Therefore, half range Fourier cosine series for f of x is f of x equal to formula a naught by 2 plus sigma n equal to 1 to infinity an cos n x. Already we determined a naught and an. We got a naught equal to pi plus sigma n equal to 1 to infinity. That particular, if n is odd, we are getting an. For n equal to 2, 4, 6, we are getting 0. So n equal to 1, 3, 5 like that, you will get minus 4 by n square by pi, n square into pi cos nx. Here f of x, the given function is f of x equivalent to x. Therefore x equal to pi by 2. Minus 4 by pi is free from n, so you may write down outside of sigma notation. N equal to 135 cos nx by n square. This is the required Fourier, half range Fourier cosine series to the function x. To the same problem, they ask find half range Fourier cosine and sine series also. So they ask half range together with the half range Fourier cosine series. They ask half range Fourier sine series also. Now we are finding sine series to the given function x. Half range Fourier sine series is given by f of x equal to sigma n equal to 1 to infinity bn sin nx. Fourier sine series contains only bn terms. So to find bn here, formula given by bn equal to 2 by pi integral 0 to pi f of x sin nx dx. So it is equal to 2 by pi integral 0 to pi f of x is x sin nx dx. To evaluate this integral, under the integral we observe algebraic and the trigonometric. So we are going for generalized rule of by parts. Take u equal to x and v equal to sin nx. For u derivatives, u dash 1, u double dash 0. For v integrations, v1 equal to integral of sine is minus cos nx by n. v2 equal to, for cos integration is sine, so minus sine nx by n square. So according to the generalized rule of by parts, integral uv dx equal to u v1, that is minus cos nx by n, u v1 minus u dash v2, one more minus sign here, so sin nx by n square, u v1 minus u dash v2 plus u double dash v3. Already this is 0, so the formula stop. Now by substituting upper limit 2 by pi Here in place of x, pi, cos n pi minus 1 whole power n. So pi into cos n pi value minus 1 whole power n by n. Sin n pi 0. So minus of lower limit 0 into this term 0. Here sin 0 0. So pi cancel. So you will get 2 into minus 1 whole power 1 more minus sign. So plus 1 by n. This is Bn Fourier coefficient. So half range Fourier sine series for f of x is f of x equal to sigma bn sin nx. So sigma n equal to 1 to infinity. Bn is 2 minus 1 whole power n plus 1 by n sin nx. As a 2 free from n, so 2 n equal to 1 to infinity minus 1 whole power n plus 1 by n sin nx. This is f of x is x half range Fourier sine series to the function x. You will get a doubt. Here f of x equal to x is an odd function, but how we got half range Fourier cosine and sine series? You have to remember one point here. We have to check from the starting of unit. We find Fourier series to the function f of x in the interval 0, 2 pi. Observe the problem. If the interval is 0, 2 pi, if they ask Fourier series in the interval 0, 2 pi, we have to calculate A0, AN, BN Fourier coefficients. If the interval is minus pi, pi, check whether the given function is even or odd. If the function is even, we have to determine only A0 and AN Fourier coefficient and BN automatically 0. If the function is odd, we will get only BN Fourier coefficient. A0 and AN becomes zeros. If the interval is 0, pi, definitely they ask only half range Fourier cosine series or half range Fourier sine series. Sometimes they ask both. If the interval is 0, pi, we have chance to ask half range Fourier cosine series or sine series. In this problem, they ask both. The interval is 0, pi, and no need to check the function is odd or even. If the interval is minus pi, pi, then only we have chance to check whether the given function is even or odd. In that only we have choice to take like this. If the interval is 0, pi, definitely they ask either half range Fourier cosine series, sine series, or sometimes both. So if the interval is 0, pi, we will get both cosine series and sine series.